All right, now we want to talk about what do materials really do when you apply a stress to them. So far, we have discussed materials behaving elastically. So here's a graph of stress versus strain. And in that first region there, you see it's the elastic region. So what is the shape of the curve in the elastic region? It's a straight line. So the slope of the stress versus strain graph in the elastic region is going to be a straight line. And so that's exactly what this is saying. So this, the elastic modulus, would be the slope of that line there in the elastic region. However, if you continue to apply a stress to an object, it's going to start to deform plastically. You can do this with a rubber band. So if you take a rubber band, attach it to the ceiling, put a weight on it, it's going to stretch. Okay, then as long as you don't put too much weight on it, when you take the weight off the rubber band, it's going to return back to its original length. But if you put too much weight on a rubber band, you will see that it starts to stretch it out, and then when you take the weight off of it, it does not return back to its original shape. So then we have deformed the rubber band, and it has behaved like a plastic. And so that's the plastic region of that. So again, if you put too much stress on an object, it will start to behave plastically, and it does not return back to its original shape after you remove the stress. Now there is an ultimate stress that you can apply to an object, and then if you apply anything more than that, it's going to break. And so again, we could do it with a rubber band. If we put too much weight on a rubber band, eventually it is going to break. And so that's going to be the failure point when that happens. Now, engineers are very much interested in this. So engineers want to know, for example, how much force can concrete withstand before it begins to buckle. And then similarly, they want to know how much force can you apply to a girder before that girder begins to buckle underneath that force. Now, instead of the word force, we could also insert the word stress. So how much stress can the concrete withstand? How much stress can the girder withstand? And so they do this quite a bit. So they take varying amounts of concrete, different compositions of concrete to find the best one that can support the most amount of load. They want to know, for example, on a bridge, just how much weight can a bridge withstand before it begins to sag. They also do experiments where instead of squeezing something, they're taking something and they're pulling on it to see what will happen. And instead of, with this girder, instead of pulling and pushing on it, they're bending it. And they want to know how much force can they apply to it before that girder will begin to bend. They even twist them. They want to see how much of a torque can they apply to it before it begins to deform. So they need to know the strength of materials. How much force can materials take before they begin to deform? And then they'll know how to build the best kinds of buildings and bridges that will go with that. All right, let's take a break. When we come back, let's talk about how Coulomb's law for atoms is related to Hooke's law.